idea what that is? Have you heard of that before?
No, I have not heard of it.
Okay. So the valence shell is the outermost shell from the nucleus. Okay. And uh, the first valence shell, sorry, mistyping here. First valence shell has 2 electrons. The next ones have 8. Okay. So could you rewrite this in your own words, please?
Okay.
These are not really good sentences. These are just speak sentences.
I gotta rewrite what you typed, basically.
Yeah, I mean, this is me like teaching to you, and then it's like, okay, now let's put that down into a sentence or two.
All right, I just typed it in the chat.
So it's always a good idea to use some of the words uh, from the problem here, which is what you did. Valence shell is the outer. Sometimes I like seeing the outermost shell of the nucleus. It has 2 electrons, and the next ones have 8. Perfect. Okay. Very good. All right. Describe the covalent bonding in each of the following molecules. You may use a verbal description or electron dot diagram. We're going to use the verbal description, otherwise drawing that could be tricky. Um, so the first one is water, H2O.
Yeah.
Why don't you do a quick search for H2O and then
Okay.
covalent bonding type and see what comes up for that. It's basically everything that's highlighted there.
It says here it's a polar covalent.
Okay. So let's do a different thing here. Let me go to your thing here. Maybe it will be easier to do a dot diagram. Most of these have uh, a well-known dot diagram. So without getting into like what is going on here, which I guess might be important, I don't know. Um, this is the diagram. This is the dot diagram for H2O. Um, it's got what's called a bent structure. And that's what I was trying to decide is if they want that name.
I see.
And I'm trying to decide here what they really want. Uh, so I think maybe going with the dot diagram could be the best way to go.
Okay.
And I take that back. Now, does your teacher allow you to submit drawings? I mean, I assume these snips are not okay, but
I don't think she does allow me to submit drawings.
Yeah, so what I was noticing in your submission box is there's no place for drawings. There's just the text box, is that right? It does look like you can upload um pictures. There's a little image icon,
Yeah.
but that could
But like
be
I can
that
only
could
upload pictures unless it's like a math work.
it says you can upload a file too.
Yeah.
I guess that's where I'm at, is like, do you want us to so the way that the description would be you would say something like this: oxygen forms a single bond with the hydrogen, and there are four electrons. So each of those dots is an electron remaining on the on the oxygen. That's what they're looking for with the description. Or you can put the diagram in, or both, I guess. Like
Mm.
it would take a lot to explain this, so that's why I'm not like it's fairly involved. Um, but these are all well-known ones. So this one, you can say the verbal description would be that nitrogen, and maybe that's kind of what they're looking for, is like nitrogen is in the center. Okay.
Okay.
And then you can say it's single bonds with hydrogen, with three hydrogens. Uh, so that you can talk about center, the single or double bonding, which we'll see in a moment, comma, two remaining electrons on the nitrogen. That's what the dots are. Any questions, thoughts on that? Remember CL2?
CO2, no.
Okay. And I always go to
Especially
images. I always think that's easier to do. So here we go. I'd like you to try to write something for this one, and keep in mind like it should follow the same form as the previous one. Basically, you should just talk about the type of bonding and the number of electrons that are remaining on the outside. So will you attempt to describe this based on kind of the previous one there?
okay. So it has so hold on. It has two bondings.
So you want to talk about a single bond. There's a single
Oh, yeah,
bond
sorry,
there.
single
And
bond. What is Cl2? It's not CO2, it's Cl2, but what does it
two
stand for again?
two Cl is for chlorine. So there's two of
Okay.
them.
It's not in the center, it has a single bond.
Yeah, there's no center on this one.
It has 12 remaining electrons
You want to say on the on like
on the
eight, there's eight.
chlorine.
Well, there's six dots. You would say six on the chlorine, so, or on each of them.
Here's what I typed in the chat. I like tried to make it the way you wanted it to.
Okay. Okay, so you want to say chlorine has a single bond uh, between them, maybe, and each has 6 electrons remaining. Or you said that there. Okay, yeah, it's good. That works. Um, so HBr, we can look that one up. I'm just going out to the internet, I'm not doing anything special to find these. Been encouraging a lot of students to use the images, Google Images, as a good place to start with
Yeah.
with a lot of stuff now, rather than all the words. But so give this one a try. It's hydrogen and bromine.
Okay. It has one bond, a single bond.
Yes.
Yeah, I just typed it in the chat. I think I did it right.
Okay. So you might reword it this way, where you say that it's just kind of putting the um, if just change kind of the order. There is a single bond between hydrogen and bromine, and bromine have six electrons remaining, something like that. All right. Okay, so what are covalent bonds? That's a pure definition. Why don't you just look that up on the internet? And you can, I think, probably okay to copy and paste on that. Your your class might have it in there as well. Let me see if your class actually has the definition. There's only 35 covalent bonds. All right. Yeah, actually, it is in your it's there.
In the lesson.
Yeah.
All right.
There's a section on covalent bonds.
Um, just give me a second. All right, let me go look at the code. Yeah, there we go. I found the covalent bonds.
Okay, so the definition's pretty clear. The two nonmetal atoms to share electrons become more stable. So you want to include the words two and nonmetal, and sharing electrons in your answer.
Very important. I just can't copy and paste the meaning. Like,
Think you can. I mean, maybe you can.
I
Um,
will. I just feel like when sometimes they ask like for a meaning, I can't just make it up on my own. I gotta go to Google because they already gave the meaning in like the first sentence, and I just typed it in the chat. Well, I copied it into the chat, but
I mean, it's your assignment. Well, see, that's you want to say a covalent bond is that's really how you start these things. So why don't we rewrite why don't you rewrite it that way? A covalent bond is, and then
Okay.
put some words after that.
All right, I just typed it in chat.
So we might say is between two nonmetals atoms, and they share electrons to become more stable. Okay. Um, Now we just answered the next part. What type of elements are usually between? And why do they form is probably a more challenging question to answer. It seems like beyond the scope of this course. So the answer is that they and you've actually answered it here, is to become more stable. Um, so this probably answers everything. I mean, I'm content
Yeah.
with it. Okay, let's go back to your assignment and find the next couple of questions here. All right, so the next grouping of questions is about ionic bonds. Okay, so an ionic bond is you're gonna want to look up here. It says when a metal and non-metal combine together. So of course, the first question is what is an example of an ionic bond with a 1 to 2 ratio? Um, Let me actually go to that link and see if it gives us any more information. 1 to 2 ratio. Okay. So an easy one here is MgCl2. Um, the ratio means that there's 1 magnesium, there's 2 chlorides. Now, if you're wondering how I got that, there's a periodic table in your
In the
your thing
lesson,
there.
yeah.
Yeah, in the lesson there. So let me go grab a snip of it and I'll try to explain. Um, so Mg is in the second column, so it has a +2 charge. Sometimes you even see that written. Cl has a -1 charge because it's over here in the last column. So it's like +1, +2. Boron and aluminum are +3. Carbon is +4, -4, but then you go the other direction. Nitrogen is -3, oxygen and sulfur -2, F and Cl are -1. But since you have two of them, that's why that's where you get the ratio of 1 to 2.
Hmm.
Okay. So what I'd like you to do is write a sentence that says, the 1 to 2 ratio means that you have 1 magnesium and 2 chlorides.
Wow, this is What? I still don't
This,
understand it.
just the sentence that says one magnesium goes with two chlorides. That's what a 1 to 2 ratio is.
Okay. So I
And you
should
might
just
even,
type that out.
or you might even add that an ionic compound is a metal and a non-metal when they're in the 1 to 2 ratio, which means that you have one magnesium with two chlorides.
All right. So I should just like type that out. So I should type like magnesium has an ionic compound with a 1 to 2 ratio.
And you want to start by talking about what an ionic bond is. An ionic bond is a metal and a non-metal. Okay, I would start with that. Then add in a, something with a 1 to 2 ratio means that you have one magnesium and two chlorides.
All right, here's what I have typed out.
Yeah, good. This is great. So we're just gonna just reword it slightly here. Ionic bond is a metal and a non-metal. Okay, and you might say ionic compound is a bond between a metal and a non-metal. Magnesium chloride is an example of a 1 to 2 ratio, comma, it has two magnesiums and one chloride. Well, it does not have to, the charge is +2. How many chlorides? It's two chlorides, two minus ones goes with one plus two. So just reorder that there. And now you have it. All right. Good job. So the next grouping of questions here, kind of the same thing as before. Why don't we look up the dot structures, LICL? I'll do that for you. Um, in a true chemistry course, you'd be expected to want to do these on your own, but I guess I guess you don't have much to do. I guess they don't. I guess they're not. I don't know if they're even teaching how to do this in there. Um, so what do they really want here? Sorry. Is it illustrate the following ionic substance? Just link up with these images. All right, let me. Yeah, that's right. Okay. Trying to find out if there's a website where you can look these up. Lewis dot structure. Let me see if this one is any good. Yeah. Um, do they give an example in your notes? Because these aren't typically drawn this way.
I don't see anything.
Yeah. Oh, okay. Yeah, it is here. So this is what they're this is what they're asking you to do. And so I think it'll be kind of hard to draw. Okay. Uh, so this one is from your notes. This one's an example of NaCl, and it follows very closely. LiCl follows very closely because it's essentially the same drawing, but with Li where Na is. Um, so the way it's supposed to be drawn is you're supposed to put like the number of electrons in what's called the outer shell. So we have again, we're kind of at a crossroads here. Do you want to try to describe this, which seems really difficult, or draw a picture and upload it?
I'm sorry, can you repeat that?
What do you want to do to submit this? Do you want to try to describe this in words or draw a picture?
Let me, I'll draw it.
Okay. Well, this is not the right one. This is for NaCl, but Li is essentially the same. You just replace Na with Li in each of these.
Okay, let me just get my notebook and pen and I'll just draw each of them out.
Okay.
Okay, I got it. I think it out would be way better than trying to describe it because, okay. So I replaced the Na with Li, right?
So the thing is though, is there's actually a number of ways to represent these. And I don't really know what your instructor wants here. Boy.
So you want me to replace the the Li, right? I mean the Na with the Li, right?
I'm trying to decide if this is the right way to do it. Give me just a moment here because I don't know what your instructor wants. I'm trying to look through the examples, and then I think what they want is more of what I'm putting here, which is the so let me replace here. So I can certainly explain here. What we're trying to do here is you're showing the element in these brackets, and then because it's a plus charge, you put a plus here. The Cl is also in brackets, but it's a minus, and then you're showing that they're sharing these two, but Cl's got the kind of the remaining ones. Uh, that would probably be the best way to show this. See, I would copy this down.
Okay. So you want me to copy it down like that? Okay, cool. Gotcha. Um, okay, I copied it down the way it would. Question for the L, I think. Okay. Drum. All right. Number 3. Okay. I copied all of those down.
Okay,
All right. Number 4. Let me write that one down too. So this, I have to do something similar in chemistry for next year, right?
well, it'll be more explanation. Like we're just sort of like not worrying about the details, but you have to figure out which one goes in the center, and then you have to know whether they share one or two, whether they're singly or doubly bonded.
So
And
you're basically trying to make a bond.
yeah, the shared electrons make a bond,
I see.
and that makes them more stable.
So they're just giving me a little snippet of what's going to happen next year.
Exactly. Exactly. It's like they're covering that in a for we've seen that in all the lessons. There'll be a lot of repeat next year.
Okay, I got it.
All right. So that is another kind of section of questions down. It's really good. Um, but we've talked about uh, covalent bonds, ionic bonds, and then let's see where we're going from here. So polyatomic bonds. All right. So we're up to question 6. Does that seem right? Question 6. Yeah. All right. So what you're doing here to answer these questions is you're deciding whether it's a metal and a non-metal or two non-metals like we were looking at before. And that really comes from your periodic table. So I'm going to go grab a snip of that. So NaCl, Na is over here on the left, Cl is on the right. That's a metal with a non-metal. So is that a covalent or an ionic bond? That's kind of where you're at right now. Is it two metal? Is it a metal and a non-metal, or is it two non-metals? NaCl. Na is a
Uh,
metal, Cl is a
CL
non-metal.
is, yeah,
So is that ionic or covalent?
it's ionic.
Okay. All right. How about the next one?
Ca is C. Okay, I'm gonna find F first because wait, what am I doing? I can use the periodic table website that you sent me from last time. It's easier. Okay, CaC. Okay, calcium is Ca. Calcium is a metal. F is a non-metal, so that's ionic.
Okay. Now H2 means that there are two hydrogens. So whatever hydrogen is It's doubled up.
So it's a non-metal, so it's covalent.
It's covalent, two nonmetals. Okay. Now, AR is just a single metal. Let's make
Okay.
sure I copied that right, because I don't know why it's by itself. Um, so AR is just a single metal.
So
So
what would
I don't know,
we write in
I
this
don't know.
situation?
I guess just an atom. It's an atom,
Okay.
maybe single metal.
S.
All right.
So
SO2.
they're both non-metals, so they're covalent.
They're covalent. Now, it says which type of substance, and typically these are called polyatomic ions, which is covalently bonded. But I think that they want a little more here. I think they want you to say polyatomic ion. Maybe say covalent. Same with the next one here. Well, no, that's not even right. C6H12O6. That is in your lab somewhere. Not lab, that's in your lesson somewhere. It's I don't want to tell you what it is, but let me see if I'll just do a quick keyword search. No. Okay. Why don't you look up on the internet what C6H12O6 is?
Okay. Oh my God, that's a lot. Okay. Let me go search that up. All right. That's glucose and I don't know what else. Hydrogen because
What's another name for glucose?
um it says here that it can also be known as dextrose, but I don't think that's right.
Like sugar. Sugar.
Oh yeah, that too. I
Okay.
for, I don't know
So
why. Sugar
so
should have been the first thing that came into my head because plants.
right. So O2. O2 um is two nonmetals. So that's covalent. Why don't you look up potassium iodide either in your on the internet or in your lesson? Actually, it's not in your lesson, so I guess they didn't give you very much here. Is potassium a metal or a nonmetal?
Um, Potassium is I don't know actually. One second. I feel like it is a metal. Just let me just Yeah, potassium's a metal.
Right. What about iodide? Is it a metal or non-metal or what is it?
What is the symbol for it, by the way? I'm trying to find out.
Best, always good to just do an internet search for that. So you're comfortable. And you can always you kind of go with like, okay, well, maybe it's the first letter, but in the case of potassium, potassium's K. not always. Um, not
Okay,
always the
I
first
that's why
letter.
I'm searching it up. Okay, it says for iodide it is an I, so
Yes,
that
over
means
here.
it's 53 and non-metal, so that's an ionic bond.
It is ionic. Very good. All right, good job.
I never really understand periodic tables sometimes. It would be easier if everything was just like the first part, the first initial, I mean the first letter of their name. That would be way easier, but people are
There's
extra, I guess.
there's overlap. Hydrogen and helium starts out right away, so it doesn't, unfortunately, just doesn't work that way. All
True.
right. The next is physical or chemical change. Physical are things usually you can like see. Um, Chemical, well, we'll get to. So you chop down a tree in the woods and bring home the wood. Actually, let's go back and read the difference between physical and chemical change. In a physical change, matter changes in form or appearance, but not identity. Okay, a chemical change, there's a change in the substance. Usually some sort of reaction occurs and a different substance with different properties is produced. So you have to decide, is the wood from the tree really different from the wood you bring home?
No,
No, this is physical.
it's just the physical appearance, yeah.
And actually, let's put the answer in front. That'll be easier for your instructor to grade. All right, you burn the wood. Does it change when you burn it?
Yeah, it becomes ash.
Yes, that's a chemical change. All right. An iron nail left outside rusts. So is the rust a physical or a chemical change? Is the rust the same as the nail?
No,
No, that's chemical.
yeah. I can confirm that because my skates have rust on them
Yes.
because they're old. I'm getting new ones soon, so
All right. How about ice melting in your drink?
that's I'm gonna say that's a physical reaction. The ice is just part of the water now. It's
Okay.
still there basically, just in
Yeah.
its
Now when
actual form.
it's adding flavoring to a drink is a little bit different.
Yeah.
Are you changing it when you add flavor?
Yes, you are.
Yeah,
It
you are.
it because it could be flavored with a specific color. Like Kool-Aid is a good example with that, you know.
That's right. All right. How about your broom loses bristles while you're sweeping?
Physical.
Okay. How about the next one?
That's a chemical reaction. I
Okay.
Yeah.
How about and the key word here in the last one is the bubbles. The bubbles.
Piece of zinc placed in acid solution raises the temperature of the solution and creates bubbles. That's chemical.
It is chemical.
Yeah.
All right. We're gonna stop there for now. I'll see you in about 10 minutes and we'll work on either the rest of this and something else. So just kind
All
of
right.
figure out what you want us to do. Thank you, Ivana. See you shortly.
Thank you.
Bye.